Okay, what we're going to do right now is we are going to work on the power property of logarithms. Okay, and what the power property of logarithms tells me is that if I have a logarithm and its base is x of, let's say, number a, and that will be equal to, or a to the c power. Okay, what that's going to say is if I have a logarithm with a base x of a to the c power, what I really can do is I can kind of pull that c out and just multiply it by the logarithm. Base x of a without that exponent here. So this ends up being pretty useful at times to help us solve equations, to kind of simplify things down. So let's go ahead and see that proof and why it works. Okay, so there's two basic facts that we just kind of want to deal with. And the first is that if I just have a logarithm base x of a, it will be equal to just some number. Let's call it b. Okay, and then from that, we know that with my properties of logarithms, that means if I take x to the b power, that's going to be equal to a. All right, and that's the power of logarithms. You've heard me say this before, that what logarithms help you do is they help you find the exponent when you're given the base and what it's equal to. And it's extremely helpful when it's not easy, when it's not like 2 to what power is equal to 8. Well, we know that the power needs to be 3 because 2 times 2 times 2 is 8. These ones will help you find, or logarithms will help you find more complex ones. So let's just go ahead and start with that basic logarithm. That logarithm base x of a is equal to b. And let's just use a property of equality and multiply everything. Let's go ahead and multiply everything by a number c. So now I have c logarithm base x of a is equal to b times c. And you know what? We can actually do that exact same thing with this one as well. And that would be, or something similar, not the same. But what if I just take this x to the b power and I raise it to the c power? Well, then, if I'm going to raise one side to the c power, I'm going to have to raise the other side to the c power as well. Okay? And then from that, we can really derive some important stuff. So what's our property, or our exponent properties? Okay, if I have a power to a power, that means I know that x to the bc is going to be equal to a to the c power. Okay, and so we can go ahead and use a logarithm. Okay, so we can go ahead and use a logarithm here to say that if I have a log base x of a to the c power, that's going to be equal to b times c. Now, b times c is equal to logarithm base x of a to the c power. So as I'm looking at this, I actually kind of know something else that b times c is equal to. B times c is actually equal to, if you look over here, it's equal to c times the logarithm base x of a. So I can just completely replace b times c with this. Let's go ahead and do that. So logarithm base x of a times c is equal to c times the logarithm base x of a. And that right there is actually the power product, or the power property of logarithms. And basically, again, what that is saying is if I have a logarithm base x to some, and then a number to a power, I can pull that power out and just end up multiplying it by the logarithm with that exponent absent.